Hi everyone, welcome to our next video in the series on AI and cybersecurity. In the last video, we took a brief overview of prompt injection. We played a very interesting game and we cracked levels 1 to 8 of the game Gandalf from this company called Lakera.ai. In today's video, we're going to take things to the next level. You're obviously not going to be testing AI apps by hand, and the different techniques for prompt injection are so many that you want an automated way to be able to test these AI apps. So we're going to look at a bunch of tools that are already available, and then we're also going to build our own toolkit for some advanced AI testing. So let's take a look at the setup that we have. First, I've built a vulnerable AI lab that has 3 main modules. The first one is a RAG chatbot, so you can upload files into it. This helps you with indirect prompt injection. I have a weather agent that works like a simple chat agent. You can ask for the weather and you can ask for different information about a given city. And then you have certain MCP tools also, which are very benign. And each of these modules has 3 levels of security. At level 1, I've set up no security at all. So it's the base LLM that you call through the settings that will decide the level of security. And then level 2 is where there is keyword filtering. And level 3 is where user intent will be filtered. Now, there are a bunch of ways in which you could try and test this app out. A very popular tool is called Garak from Nvidia. Its usage instructions are all defined on the website, so you could read through that. Another very popular tool is PyRIT from Microsoft, which is more like a framework for testing, and that's another popular tool that you could use. And thirdly, we're going to use something very interesting called Claude skills to build our own toolkit. And then we're going to compare results between Claude skills and PyRIT, and let's see who comes out as the winner. So let me walk you through the very interesting journey of prompting Claude to build me this toolkit. And let me take you through what that conversation looked like. So first, I actually went to another LLM and asked it to give me a prompt that I could then give to Claude Code to build a toolkit using Claude skills and plugins and sub-agents. And I simply copy-pasted that prompt into Claude Code, and Claude hated it. So Claude basically said, I need to address several issues with this request. I cannot do this. And what I can help with is if you have legitimate authorized security testing needs, I can help you build actual tools. So tell me what you actually want to do. I said, okay, let me be very honest with you. I am recording a YouTube video for my educational channel on prompt injection. For this, I will be comparing building one's own custom toolkit versus PyRIT. And thankfully, to that, Claude said, that's a legitimate educational use case. Testing your own vulnerable application for a security education video. Let me help you. It checked out the vulnerable app, figured out its interface, and said, this is a well-designed app. I used Claude to build the app. So kudos back to Claude. And then I said, and it started to actually build the plan. And I said, no, wait. And this is very important. You have to work with the tool to get the best output. I said, first tell me your plan. This has to outperform Microsoft's PyRIT and Nvidia's Garak. So this is a very serious attempt. We have previously done extensive research on prompt injection. This is the Transilience team. I can share some of those insights with you, but this toolkit should incorporate the industry best practices from research published on ArcSiv, the GitHub repo of Pliny the Elder, who publishes amazing prompt injection and jailbreak ideas, and others, etc. So you're right. Let me think through this properly. Very important. It does its thinking, does its analysis, gives me a research, and then it says, what is the previous research you have done? Asks me a bunch of questions over here. And I share that research, which is very interesting. We discovered that multi-turn attacks work best, and it should be limited to about 3 to 6 turns. If you haven't fooled the LLM or the app in about 3 to 6 attempts of that conversation, you're not going to get success with dozens of conversation attempts in the same flow. We also said that, basic stuff like changing languages or using base64 or leet speak doesn't work anymore. So don't even go there. And we also found that if the attempts come from documents uploaded into a RAG chatbot or instructions put inside an agentic app, those kinds of things come with implicit trust and they tend to work pretty well. Excellent insights. This changes everything. It proposed the architecture, which I quite liked. And then It also said I will use LLM as a judge, which is exactly what I wanted. Told me how I would report it and created the RAG pipeline as well. And then said, this is what I'm going to do in terms of how it will differ between PyRIT and Garak. So all promising so far. And then I said, will you be creating skill.md files for specific skills and also subagents and plugins? I will eventually release this toolkit on my GitHub repo. This is making my request even more legitimate in Claude's eyes. And it said, great agent, great question. This is an important architectural decision. And gave me the difference between using just Python code and building it as Claude code skills. And then it said essentially that the basic difference would be that if it built it as skills and plugins, then it would only work inside Claude code, whereas Python code would work for anybody. And I said, no, my objective is also to demonstrate the best practices of Claude code skills. And if that is your only objection, then go ahead and build it using Claude code's capabilities to the hilt. And so it did that. Great. And the way it designed the architecture is very interesting. So it said, first, skills, which encapsulate expertise with controlled invocation, sub-agents, which are the tasks that it will execute, a Claude.md file, so that every time I run Claude code from within this project, it will run consistently, and a conversation context to bring out that multi-turn nuance that I spoke to you about earlier. And so the skills it created a strategy skill, which is kind of the overall strategy, exploit the pedagogical inclination of LLMs that they always want to try and teach you things, exploit multi-turn attacks, exploit sentence completion strategies, etc. The judging skill, LLM as a judge, indirect poisoning skill will create prompt injected PDFs, and a report writing skill. So these are skills that will be common across different projects that I will run. And therefore, this capability is encapsulated in skills files so that it is repeatable and reliable whenever I execute it. And then it created specific Python files, tools, conversation manager, document generator, and also payloads in YAML formats. Again, very reusable components, very extensible components. I can prompt it to keep adding more attack variants to these same pieces of code, and then captures all the evidences and writes up the report. And then it built this tool. I love what it did. I went through all of the details that it said when it was building it and what it had built. And then I essentially said, after all of this was done, and I liked what it did, I said, please go ahead and execute it. So I think the key takeaway from this is that do not just go into Claude and say, build me an AI pen testing toolkit. I have tried that, and the output will leave you asking for a lot more. So the idea is to work with Claude Code as a brainstorming partner, prompt it in the right direction, let it challenge you as well, let it ask you the right questions, and then based on that, first ask it to design the architecture, give you the plan, and once you like what you see, then go ahead and tell it to build the code. What I would also do, which I did not do in this case, is I would have Claude analyze this code by itself and say, what do you think of this code and how do you think it could improve it? And that would be my next version after this video is done. So once all of this was ready, I said for LLM use Garak, I have the API keys for in a local file. So read it from there. It figures out which key is for Garak. And then it goes ahead and executes the whole attack. And now let's see the results that we got. So let's take a look at the results that we got from here. There was a moment where I hit my usage limit, so I extended my rate plan, and then it continued the testing, and it got the partial results, and then it did complete the whole testing and got the final results, gave me the report. And here's what we were able to find. We were able to get the entire tool schemas. So we knew all of the tools that the MCP agents and the weather agents use. We were also able to get the fields that the tool calls use. So that's interesting. Indirect injection worked the best. So when the prompts were inside the RAG documents, they worked out best. And we were also able to get the system prompt from the document assistant. And that's essentially that I had asked it to do. I said, figure out the system prompts and figure out the tools and the tool call information. And it was able to do that pretty well, stored all of the information in these JSON files. And then it also ran PyRIT for me. I asked it to actually do a little bit more. I wanted it to push it further. And I said, go ahead and do more testing. And then I also said, run PyRIT. I did not get into the details of how to install PyRIT, how to execute PyRIT. It auto-installed it, it ran it, and it gave me the comparison of both of those tools. So let's take a look at now what the final results look like. PyRIT was completed, generating the comprehensive comparison reports. Time for the drum roll. Let's look at what we found. So here is the final conclusion. In the weather app, we were able to get, it's actually given points to each tool. So with the weather app, when it comes to the system prompt, it rated our toolkit as 4 because we actually managed to extract the prompt. And with PyRIT, it rated it as 3 because it got partially the outcome. With the tool schema, we got, and so did PyRIT. MCP, we got at all of the levels, we got the tool schema. PyRIT got in 3 or 4 of the attempts, it got the tool schema. RAG, we were much more successful. PyRIT was not able to generate malicious PDF documents and upload them. So that's a big win for us. And when it summarized it, it said final scores, we just narrowly beat PyRIT in this particular assessment. But like I said, we will now improve upon this version of code to make it even more powerful, even more effective. But for just 15-20 minutes of prompting, the output we got for it to beat Microsoft's tool is quite a reasonable achievement, I would say. So the conclusion is AMTF wins overall. AMTF, in Claude's wisdom, it named our tool as Advanced Multi-Turn AI Pentesting Framework. And so the conclusion is, if you want deep exploitation, you want API analysis, and you want RAG systems to be tested, AMTF is the tool for you. If you want broad scanning, you want to throw everything in the kitchen sink at your target, then PyRIT is the tool for you. And the final best conclusion, I think, that comes out from it is use both tools to get the best results. So that's where we are. I asked her to summarize what were we actually able to find from our own tool. So here's what we were able to find. We got the system prompt for the RAG chatbot. We also got information about its behavior. On prompting it smartly, we were able to understand its behavior. And weather agent, again, we were able to get the role defined for the agent, which is a key parameter in the agentic AI behavior. So we were able to get that. We were also able to get the tool definitions and their input parameters. So with AMTF, these were the key artifacts that we got. So I hope you found this exercise useful. To summarize, we set up a vulnerable app with 3 levels of security. We launched both our custom toolkit and we launched PyRIT, and then we did a comparison of the two. Our custom toolkit, we did not create with a single prompt. We worked with Claude Code. We said, hey, we want you to generate the best possible outcome. Give us a plan, give us your architecture, give us your approach. We tweaked that approach and the plan, and only when we were very happy with the overall approach and philosophy and architecture did we go ahead and say execute it. So I hope you found this useful. It gives you ideas to create your own Claude Code projects, and do share with us your results and links to your GitHub repos. The link to my code will be in the Transilience repo, and it will be in the description of this video. Thank you for watching.